This was the concept we covered in. My screen is visible, right? It's clear.
Yes, ma'am.
Yes, ma'am.
Yes.
So, what is the average weightage of the classes? 38 students are fine, or anyone is going to be joined this? Any one of you, do you have any idea about it?
Previous city also
Yes, ma'am.
joined.
Like in general, like this, like
Okay.
50 or 60 students.
Normally the classes from 2 to 4 now, so that time maybe similar strength will be there, and some of the any special cases now, so it will be more. But due to the Dasara now, so that's why it's a strength. Otherwise, it will be almost 80 to 90 average. It will come. Some days
Okay.
maybe it will go 150.
Okay. Then we can start. We will not wait more then. I think no one is
No,
going
it
to.
is a recorded session available, madam. So you can start
It
immediately.
will
So who
be.
are missed, no, so they can watch in
Yeah,
the offline videos also. So it's better we don't want to wait
yeah.
and
So we will start.
record it, madam. So that's also important.
Yeah, it will be also live streaming, so no problem in that. So we will not wait more. We will start the concept. Okay. So what was quadratic function? Quadratic function, you all know that quadratic function is nothing but a polynomial of degree 2, right? So we can express them as y equals to some ax square plus bx plus c. This is the typical standard expression for a quadratic functions, right? So this is the quadratic term of the quadratic function. And what do we know that a quadratic function typically looks like a parabola. That means like this or like, right? Depending on the constant, the coefficient of x square. So if a is greater than 0, then we will get a parabola like that. That means a parabola in the upward direction. And if the constant a is less than 0, then we will get a parabola in a downward direction, right? That you already know. And if
Yes,
you
ma'am.
have some quadratic equation, then we know how to plot the graph of the equation, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So if we have a parabola like that, that means we know the this midpoint. Typically, we can call this as midpoint of the graph. This midpoint is called as vertex of the parabola, right? And the line which passes through the midpoint is called the axis of symmetry of the parabola, right? This is the axis of symmetry of the parabola. That means if we just fold the graph of the parabola with respect to this line, both sides will coincide, right? This is the axis of parabola. This is the vertex. So if we have some quadratic equation with a as positive, then we will get this type of parabola. And these edges are infinitely moving, right? So for this kind of parabola, we can get the minimum point, that is the vertex, right? The vertex is the minimum point of such kind of parabola. That means for a upward parabola, the vertex is the minimum. And the downward for this kind of parabola, the vertex is the maximum, because in the downward direction it tends to the minus infinity, right? So this vertex is the maximum. So if you have a quadratic equation, instead of doing this derivative kind of thing, we can simply calculate the vertex, which is nothing but minus b by 2a, right? The x coordinate of the vertex, and y coordinate will be a for
X.
minus b by 2a, right? So this is the coordinate of the vertex, right? So instead of doing this derivative kind of thing, we can just compute the vertex and we can comment about the maxima and minima for specifically the quadratic functions. Okay. So this is basically the standard form. We can write this equation in another form, which is x minus h squared plus k. Okay, we can express this equation in this form. So this is also a standard form of equation of a parabola. And if you have something like that, we can directly compute that. You can directly conclude that hk will be the vertex. Okay. Here we had to calculate the minus b over 2a and f of minus b over 2a. But if you have the parabola in this, the equation of the parabola in this form, then we can directly compute the vertex and it will be h comma k. Okay, so this is the second form of a parabola. So this is about parabola. So if you have some equation ax squared plus bx plus c, this is the equation of a this is a quadratic equation, right? So this type of equation is basically called the standard form of a quadratic equation, right? So also we have another form which is called intercept form. This is something like that. Y equals to this. So this is another type of form. This type of form is called the intercept form. So clearly, if we have a quadratic equation in the intercept form, we can just multiply this to polynomial, then we will get something in the standard form, right? And the thing is basically vice versa. That means if you have something in the standard form, we can also express it in the uh, intercept form, right? So what is the importance of the intercept form? If you know what is the root of a quadratic equation or any equation, root means basically if we set y equals to 0, then we will get the function of x will be equals to 0. And from here, we will find some value of x, right? Those values are basically called the roots of the equation. And roots are basically nothing but the x-intercept of the equation. That means this is our x-axis and this is our y-axis. Because we are equating the y-axis equals to 0, that means the solution will be in this line. That means in the x-axis, right? So whatever solution we will get, it will lie in the x-axis because only over the x-axis, the y-axis will be 0, right? So the graph will be maybe something like that. So these are the roots of the graph, or you can say the x-intercept of the graph. Okay. Up to now, these concepts are clear, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So if you have this standard form, we can express them in the intercept form, which will help us to compute the root. Okay. We know one method called FOIL method. Using FOIL method, we can express the quadratic equation from standard form to intercept form, right? So what did this method basically say? The coefficient of x square into a multiplication with the coefficient, the constant term is basically equals to coefficient of x. If we simply represent this like that the coefficients, okay, these are the constant. So multiplication of these two terms will be same as multiplication of these two terms. If we have some equation in a standard form, we can break the equation in such a way such that this holds, then we will get the intercept. Okay. So for example, we can compute that if we have some y equals to suppose 5x squared minus 13x plus 6 equals to 0. So suppose this is our standard form. Suppose we want to express it in the intercept form, right? So we have to express this equation in such a way such that this holds, right? So what is 5 into 6? The coefficient of x square is 5 and the constant term is 6, right? So the multiplication is 30. So basically, from here, we have to break minus 13 in such a way, sum of such two numbers such that their multiplication become 30. Okay. So definitely we can make it as minus 10 minus 3, right? Then minus 10 into minus 3 will be 30. Okay. So we can break them x squared minus 10x minus 3x plus 6. Then we can take common some factor. So we can take 5x as common, then we will get x minus 2. Here we can common 3 as common, then we will again get x minus 2, right? So from here we will get x minus 2 and 5x minus 3. So we had a equation in the standard form, and using the FOIL method, we basically express the equation in the intercept form. Okay, so now we can easily calculate the root of the equation. We can equate both the factor with 0, then we will get the root easily. Okay. So this was one method, and second method we had completing the square, right?
Ma'am, the FOIL method and the factorization is same thing.
Actually, factorization means what? You have something, you are doing the factorization, and FOIL method is just a method to do the factorization. Okay.
Okay, ma'am.
Factorization is not a process. Factorization is a final result. We want to do the factorization, right? Using the FOIL method. Okay.
Okay, ma'am.
So up to now it's fine, or if you have any doubt, you can ask.
Ma'am,
Anything, any doubt? Huh.
yes, I have doubt in week 2, some squared error.
Sum squared error. Sum squared error was from week 2, right?
Yes, I don't actually understand like what is happening in I understood everything, but I don't get some squared error. Like how to
Because
say.
it's okay. So because it's from week 2, I will not cover it right now. Maybe by the end I can pick the topic. Otherwise, you will have revision sessions. Then also we can
Okay,
discuss about it. Okay.
okay.
Yeah. So up to now, whatever I have covered in week 3, if you have any doubt with the concept of parabola or with the concept of the root kind of thing, you can ask. If not, then we will move. Okay.
Yes, ma'am.
Okay. So
Ma'am, I have doubt in vertex. To find vertex.
what is
And
your
also have a doubt in you mentioned before function minus function minus b by 2a. So what does mean by that?
okay? So you have this. Okay, this one, right? So this is the function of x. Okay. So we will put minus b by 2a instead of x. Okay.
Okay, I got it.
Yeah, that means you if like here you have a equation, so you will like from the definition minus b by 2a, you can only compute the x coordinate of the vertex, right? So how to
Yeah.
compute the y coordinate? Obviously, it's clear that the vertex is on the graph, right?
Mm-hmm.
This point is
Yeah.
on the graph, so it will satisfy equation of the graph, right? So if we
Yeah. Right.
have the x coordinate, we can find the y coordinate putting the value over the equation, right?
Yeah, I got it, ma'am.
Yes,
Yeah.
ma'am.
Okay. So any other doubts?
Can you explain it?
You are not audible. Can you repeat it?
Ma'am, can you explain FOIL method again?
I will explain FOIL method. Any
I'm
other
also-
doubt with the? Okay, I will explain the FOIL method.
Ma'am,
This another one, the y is equal to a of x minus h the whole square plus k. So this I don't know how it is derived actually. So
Okay.
so
So it's,
I can understand vertex, but this form how we need to arrive. So
yeah. This is just like this equation and this equation. These are basically different forms of that is how we can express the equation. This is different type of the expressions. Okay. So if we have the equation in the standard form, we can express it in this form, right? Because suppose we have this ax squared plus bx plus c. Okay, so this is your standard form of a parabola, right? So x squared, we can express it as x squared plus bx with some constant, suppose k. Okay, and we are adding k and then we are subtracting k plus c. Okay, and k we have to choose such a way so that this will become a perfect square. Okay, another way with what we can do, we can take a as common from this two, then we will get x squared plus b by x plus c, right? So if we just adjust this, like x squared plus b by x plus c plus b squared by 4a squared minus b squared by 4a plus c. That means here we are taking our k as b square minus b square by 4a. Okay. So then this will become x plus b by 2a square plus c minus b square by 4a,
4a
right?
square, 4a
So
square,
this is
right?
our,
4a square.
no, there is one a, right? So it will cancel
Okay.
out.
Okay.
So this is our k and this is our h. Okay.
Okay.
Similarly, if you have the equation in this form, you can just break the square and you can express it in the standard form. Okay.
Okay, madam. Okay.
So basically, if you have one form, then you can express it in the another form. So this is the easiest expression. From this expression, you can calculate the vertex more easily. Okay, Alok Kumar, you have raised your hand. So do you have any doubt? If you have, you can unmute yourself and ask.
Ma'am, sorry to interrupt the class, but I joined too late today.
It's fine. The recorded version is available.
Ma'am,
You can.
did you discuss about slope of quadratic function?
No,
Or
not yet. No,
Okay,
not
okay.
yet.
Okay.
Okay, so
can you explain FOIL method?
I will. So FOIL method is what? FOIL method means if you have a standard form, using the FOIL method, basically you can express the equation from standard form to the intercept form. Okay. And why are we interested to express the equation in the intercept form? Because using the intercept form, we can easily calculate the root of the equations. Okay. Also, sometimes obvious, I will explain the method. So FOIL method says that the yes. Okay. So FOIL
Ma'am,
method
can you
basically
explain this method?
Yeah, I'm explaining this. I am explaining. So FOIL method basically says
Okay.
the coefficient of x square and the constant term. If you pick the coefficient of x square and the constant term, if you multiply them, the multiplication will be same as the coefficient of x. Okay. That means if you have equation in the standard form, there is some coefficient of x, right? So you have to basically break the coefficient of x in such a way such that the multiplication of these two component will be equal to the multiplication of coefficient of x and the constant term. Okay, this is the FOIL method. So here, for example, we had the equation in the standard form 5x squared minus 13x plus 6 equals to 0. Okay. So here the coefficient of x is minus 13. Okay. So our target is to break minus 13 in such a way such that the multiplication of these two component will be equals to 30. That means 5 into 6. Okay. 5 is the coefficient of x square and 6 is the constant term. So the multiplication is 30 and we have to break minus 30 in such a way such that the multiplication of these two component will be 30. Okay, so this is basically a trial and error method. So from that, we can easily observe that if we break minus 13 in minus 10 minus 3, then minus 10 into minus 3 will be 30 again, right? So if you
Yep.
break this in this way, then we will get this type of equation. Okay. Now we are taking 5x common from this two factor and minus 3 common from this two factor. Okay. Then we can take x minus 2 this factor as common. Then we will get this. Okay. So that is how using the FOIL method we can express a equation from the standard form to the intercept form. Okay, it's clear now.
Okay. So, yeah,
Yes,
I
the,
got
Madhav.
it.
and the last derivation that you have did just few moments ago, I didn't get it.
Which one?
The last one.
Last one we mentioned clearly. This line or this line.
And no, just the doubt that she had asked just before it.
That means this one.
Yes,
This
yes,
one.
ma'am. This equation, yes, ma'am.
Okay, so for a parabola, we had two type of equations, right? One was in the standard form, ax plus bx plus c, and another one was a plus x minus a squared plus k, right? It was two kind of different type of expression we had, right? So from this equation, we can easily compute the vertex, right? Which will be h. Okay, so obviously our interest goes on how the two type of formation basically connected. Okay, so if we have some quadratic equation of a parabola in the standard form, we can express it in this form also, and vice versa. So if we have something like that, we can clearly break the square. You know a minus b whole square formula, then simply calculate and you can express the equation in the standard form. Okay, and how to do the reverse thing. So if we have this equation, avoid this line, this equation, we are balancing this equation in such a way. First we took a as common, then we get this equation. Okay, then we can express this b minus a as 2 into b over 2a. Okay, so if we want to make this term as a perfect square, then we have to balance it with a constant, right? So we added this constant, and if because we added this one extra, then we have to subtract this, right? So we subtracted the constant again. Okay, then we get the equation in this form. Okay, it's clear?
No, ma'am, I didn't get.
Why? What is the problem? What
This is
is
quite,
the point you are not getting?
ma'am. In this one, after the a in the equation that you just cut it out, just down below it, the x square plus b by ax. How did this term came here?
This one,
Just before, just above it.
this one.
Yes, yes, ma'am.
We're taking A as common. So from this two term, we are taking A as common.
Okay.
So it will be x square plus b by ax, right? Because here there is no a, and c is as it is. We are just taking a as common, nothing else.
Okay, then a is not in the bx, na?
So a is the coefficient of x then become b by a, right?
Coefficient
Now
of
we can balance the equation in such a way so that this become a perfect square.
Mhm.
Ma'am,
Sorry to interrupt,
depending
but
upon the
here,
thing.
ma'am, trying here, ma'am. Am I audible, ma'am?
Yes, you are audible.
Sorry to interrupt the class, but ma'am, here you are using the complete square method, right?
Yes, yes, yes. We are adjusting this equation in such a way such that the uh, we can express it in
Yeah,
the perfect square. We are using the completing the
yeah,
square
ma'am.
method.
Got it, ma'am. Got it.
Okay. Got it, right? So here is a small example of completing the square method. That is how we can adjust our equation if it is even not a perfect square. Okay. So using the completing of square method, so suppose this is our equation x squared plus bx plus c. From here we can see that we can express the equation as x minus x plus b by 2a squared plus c minus b by 4a, right? So if we want to calculate the root with the square method, so from here we can get a x plus by 2a square b square by 4a minus c, right?
Ma'am, not audible, ma'am.
No, no, I'm not speaking anything. Okay, so these are the easy step calculations. You can also do that. Just doing this. So if we do the calculating and the computing the square method, so using this method, we can get that x equals to this. That means these are the root of the, these are the general form of root of such a equation, right? That we already know, right?
Ma'am.
And
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
And
Yes,
this
ma'am.
term, b square minus 4ac, this term is called the discriminant of the equation, right? And dependent on the discriminant, we can comment over the root, whether the root will be real, whether it will be complex, whether it will be equal, whether it will not be equal. So we can comment about everything, right? So if b square minus 4ac, the discriminant is equals to 0, then we know that we will get equal real roots, right? Right?
Yeah.
If b square minus 4ac is greater than 0, then we will get two distinct real roots, right? And if this b square minus 4ac is less than 0, then we will get the root in some iota, right? Root over minus 1. That means iota,
Complex
right?
form.
Yeah.
No
In which,
real root.
yeah. So in this case, we will get only complex root. So there will be no real root. And here we are only considering the real line. So we will simply say that there will be no roots. Okay. So if we will consider only these two cases. So suppose we have a equation x square plus bx plus c equals to 0. Okay. With
That b squared minus 4ac is lesser than 0 means there is no intersection in the x coordinate, right?
yes, yes, yes.
Okay.
With suppose
And
we
it
have
will
the
be imaginary number.
yes.
That
So we will get
b
the
square minus
imaginary
4 is less than 0.
if
Yes.
this is less than 0, then we will get two roots and iota will be there in both the cases, right? And if iota is there, that means the root is complex. That means we cannot say anything whether it is positive, whether it is negative, what is it, right?
Okay.
Yeah. So if this is negative, then here we will not consider this because we are just considering the real line here. Okay. So complex cases we will not consider here. Okay. So suppose we have this equation ax square plus bx plus c with b square minus 4ac, suppose greater than 0, right? Then we will get two distinct roots, right? Okay, that we know. And suppose these two distinct roots are alpha and beta. Okay. If these two distinct roots are alpha and beta, then we can express this equation in the form x minus alpha into x minus beta. Okay, no confusion in this? No confusion,
No,
right?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. It's clear.
So if we have this kind of equation, if you can express the standard form to this type of equation, then how will be the picture? The picture will be something like this or something like that. Here there will be some constant, I don't know what is it, a dash b dash suppose. So if a dash into b dash is greater than 0, then we will get a parabola in the upward direction which will cut the x-axis in 2 points. That means because we have two distinct roots, right? So the parabola will cut the x-axis in two different points. Okay. And if the a dash and b dash is something negative, that means the coefficient of x square is negative, then we will get a parabola in the downward direction, okay, which will cut the x-axis in two different points. Okay, so these points are nothing but alpha beta. Okay, is the picture clear?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Ma'am, can you repeat this again about the graph?
Yeah, sure. So if discriminant is clear to all of you, right? So if the discriminant is greater than 0, then we will get two different real roots. Okay. So if we have two different real roots, we can consider them as alpha and beta. Okay. And if we have this, sorry, like suppose some alpha and alpha dash beta dash. So this is the expression. Yeah. So if you have some like two different roots, which is alpha and beta, then we can express the equation in such a form, right? If we equate them as 0, then we will get x equals to minus alpha dash by a dash and y equals to plus beta dash by b dash. Okay. And this alpha dash is suppose alpha, it's suppose beta. Okay. So basically, if we have two distinct roots, we can express the equation in the intercept form. Okay. If we can express the equation in the intercept form, then the point, if the coefficient of it depends on the coefficient of x square. Here, the coefficient of x square is a dash b dash, right? So if a dash b dash is negative, that means the coefficient of x square is negative, then we will get a parabola in the downward direction. Okay. And for this parabola, because we have two distinct roots, the parabola will cut the x-axis at two different points. Okay. because we have two distinct root, and that distinct root will be provided by the x-intercept. Okay. And if a dash b dash is something positive, then we will get a parabola in the upward direction, which will again cut the x-axis in two distinct points. Okay. So if we have that discriminant b square minus 4ac greater than 0, then we will get such a picture like that. Okay. It will definitely cut the x-axis at two distinct points. It can be a downward direction, it can be in upward direction, but it will always cut the x-axis in two distinct points. Okay.
And can parabola cut y-axis too?
What?
Can parabola intersect with y-axis too?
Yeah, sure. If we
2
just
points.
express, uh, if you have some kind of parabola.
No, the both points are on the y-axis.
Okay, like that.
Yes, yes, ma'am.
In this case, this is the axis of symmetry, right? So then you have to express the equation in such a way. Okay.
Okay. And then those were
If you can express this in the quadratic factor of y, then the parabola will be, the axis of symmetry will be same as like parallel to the x-axis. In that case, we will get this type of picture. Okay.
But ma'am, if the parabola cuts only the x-axis, I mean y-axis, then it will not have any real roots, right?
There will, yeah, but there will be roots in term of y. That means you will get the roots in term of y, because if you express this equation in this form, then we are basically getting a quadratic equation in y instead of x. Here, because we are talking about a quadratic equation, we are just changing the variable, and here our real variable is y.
Okay.
So these pictures are clear, right?
Ma'am, these pictures are clear, but the quadratic equation that you derived is quite complex to understand at first, as I'm not from math background.
Which one?
Algebraic manipulations were quite complex to understand for me.
So which one you are not getting? You can point it out, I will explain.
In the quadratic equation that you just proved.
This one.
No,
This one, right?
I'm little bit above.
This one.
Yes, ma'am, this is x equal to negative b plus minus root b square minus 4ac
So you
equal
have to do the basic calculations here. If you are not comfortable with this thing, you can go through it regularly. You will practice it, then you will be comfortable. No problem. These things are recorded, right? You can see the recording again and again. You will practice. You will be comfortable. No problem.
Okay, ma'am.
So if we get two different distinct root, then the picture will be something like that. I hope you don't have any problem with that, right?
Oh, ma'am, like here you write like a dash, like b dash is like less than 0 and greater than 0.
Yes,
So I know this key, if a is greater than 0, uh, then that parabola will upward and it will have a minimum value. But here why it is depend on like b also, like b dash and
because we want the coefficient of x square, right? And the coefficient, if you just break the equation, we will get a dash b dash x square. This whole a dash b dash is the coefficient of x square,
okay.
right? This is not our
Yeah.
usual a and b. These are some different constant. Okay.
Okay.
Like if the
mean that the general equation that the constant a it belongs to a dash b dash, which means product of a dash and b dash. Correct?
Yeah. Because the a is basically nothing but a dash b dash.
Okay.
So any other doubts?
Ma'am, like you explained in the, it's clear, ma'am, but like FOIL method, if you give like the numerical value, little bit like it will also be easier for this.
For FOIL method. I gave an
Not for the
example.
for FOIL method. You have explained this graph now, ma'am.
Uh-huh.
Yeah, like y is equal to a dash x square. Like in that, you can give one example now, ma'am. You're saying
Okay.
this is,
Okay.
yeah, the,
We can take this example. Okay.
okay,
This
okay, ma'am.
example, what we used in the FOIL method is x square minus 5x square minus 13x plus 6, right? It was the expression. So it is the expression of a parabola, right? And we have seen that we can express it as, uh, because we have already calculated, I'm not doing the calculation again. So it can be
X.
expressed in such a way, x minus 2 into 5x minus 3, right?
Yes, ma'am.
The expression. So suppose we want to do the like draw the graph. So the two roots are 2 and 3 over 5, right? These are the two roots. So this is our alpha 2. Suppose this is our beta. Okay.
Okay, ma'am.
And this is the expression similar to this expression which I wrote above. Okay. Right? It's similar to this. Okay. So suppose this is our 1, 4, and so on. So 3 by 5 is something less than 1, right? Suppose this is our 3 by 5. This is our 2, right? And we can see the coefficient of x square is positive. That means we will get a parabola in the upward direction, right? Which will cut the x-axis in the roots. That means we will get such a parabola. Okay? This is our 2 and this is our 3 by 5. Clear?
Yes, ma'am.
This is the parabola 5x square minus 13x plus 6. So is it clear to all of you?
Yes, ma'am.
So
So, ma'am,
it was
the roots are nothing but y, like x intersect, right?
intersects. Yeah, yeah. Roots are nothing but x. Because I already have said that we are like when we are calculating the root, we are doing what? Nothing but we are just equating the y-axis, the y function of x. That means the y equals to 0, right? And the y-axis will be 0 only over the x-axis, right? So
Yeah,
basically,
right.
while calculating the root, we are just calculating the x-intercepts. Okay?
Okay.
So all of these were the case when the discriminant was greater than 0. That means when we got the two distinct real. But if b square minus 4ac is equals to 0, that means we will get two equal root, right? Alpha alpha, right?
Yeah.
Because we are getting two equal root, then our beta will be alpha. So our equation x square plus bx plus c, it will then become x minus alpha whole square, right? Correct?
Yes, ma'am.
Yeah.
Yes, ma'am.
Then only we can get the two equal real root. Okay. So in this case, the picture will be the picture will be like that. Okay. It will touch the curve. This is the axis of symmetry. This is not y-axis. Okay. It will touch the curve at the touch the x-axis at the point alpha. Then it will bend. Okay. So in such a case, this will be the. So for example, if we have simply x minus 2 whole square equals to 0, this is a quadratic equation, right? And in this case also, we will get two equal roots. Okay. So in this case, we will get this type of. Also, we can get in the negative direction if the coefficient of x is something negative. If suppose if we have something negative here, then we will get a parabola in the downward direction, which will touch the axis at the root. Okay. So is the picture, is it clear pictorially?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so anyone, if you have any doubt, you can ask. Otherwise, we can next move to the slope.
Ma'am, from which type of sum comes the exam?
Can you repeat your question? You are not audible.
Ma'am, from week 3, which types of question comes in exam?
Okay, so if you are practicing your activity question and graded assignment and practice assignment, you will get same type of questions. Okay, there are nothing new to become in the exam. Okay, we
And
will
ma'am,
maintain the same pattern. Don't worry about it. You just practice all the questions which are provided in the portal. Then you can solve the question. Okay.
okay.
Ma'am, can you explain how to compute maxima of equation?
Yeah. If we have any equation, then we can compute the maxima with the derivative. But in week 3, this is not the case. Here we are particularly discussing about the quadratic equation, that means the parabola. So for a parabola, basically, if you have a parabola in the upward direction, then you are able to calculate the minima. And if you have a parabola in the downward direction, then you are able to calculate the maxima. Okay. And the minima for this case is nothing but the vertex. Also, the maxima is nothing but the vertex. Okay. So if you have a quadratic equation and you are asked to calculate maxima or minima for the parabola, then you just have to calculate the vertex. Okay. The maxima means the
Okay,
x
ma'am, got it.
coordinate of the vertex. X coordinate of the vertex is maxima, and the maximum value of the curve of the graph is the y coordinate. Okay. If you are asked to calculate the maxima, you have to calculate this minus b by 2a thing. This is the x coordinate of the vertex, and if you are asked to calculate the maximum value of the curve, then you have to calculate the maximum value at that point. That means the y coordinate of the vertex. Okay. Is it clear?
Ma'am, actually, I have a doubt regarding activity 3.2, question number 9 and 10. Can you explain?
Okay, so if you have doubt with the activity or practice assignments, so basically tomorrow we will have a question discussion class. Okay, so tomorrow we will discuss about the
Oh,
questions. Today, let us focus on the concept. Okay, so first clear all the concept related doubt. Then tomorrow we will practice all the questions. Where I will pick your doubts. Okay.
okay, okay.
Ma'am, uh, how many intercepts this graph could have with the axis? Two only, na?
Which graph?
No, this parabola could have only two.
Maximum number of intercepts, you are saying?
Yes, ma'am. Yes, ma'am.
Yeah. Maximum number of intercepts will be 2, because the maximum degree is 2, right?
Yes, ma'am.
So it can have 1 root, it can have 0 root, or it can have 2 roots.
Two roots.
So
What
maximum
if?
number of roots are 2.
Okay. So, ma'am, what if the parabola is tilted? Then it will having cuts in y, x, and lower, and that in the
This type of
all of the
thing
four.
you are saying.
Yes, ma'am. This one just gone a little bit of lower, so that it cuts all the vertices. Yes. Oh. Yes.
This,
Yes, ma'am. Yes, ma'am. This one.
in this case also, it will cut to
4 points. Then
but in this case, you will get a different equation. Okay. We are basically here, we are talking about the particular quadratic equation which are in the variable x. Okay. So we will not get this type of tilted parabola here. Okay.
when this such exists.
Yeah, obviously it exists. But for this type of parabola, there will be another type of equation involving both the y and x coordinate. Okay.
Okay.
But here we are using only the x coordinate because we are just talking about particular type of polynomial of degree 2. Okay. So
Yes,
in
ma'am.
your like in your exam or syllabus, in this type of parabola will not come because this is not a part of our syllabus. Obviously, this exists, but you right now you don't need to be focused. If you are interested, you can read about it. Okay.
And ma'am, one more thing. Why this parabola have this curved curvature in this graph? Because it's very strange. We have just seen this straight line and those sharp edges. Why this gets that this much curved? Uh,
Okay. So it's the parabola is nothing but a polynomial, right?
yes, ma'am.
So a polynomial is everywhere differentiable. We know. If we
Yes, ma'am.
had a sharp corner like that, then it will not be differentiable at that point. This is one reason. And secondly, if this is the reason actually mainly because it's a polynomial. It cannot have any sharp edges because if it has, then at that point the function will not be differentiable. So which is a contradiction, right?
Okay.
Any other doubt?
Hello.
Okay, ma'am.
Hello.
Hello. Yeah, yeah.
Madam, as per the quadratic formula, it is minus b plus or minus root of b squared minus 4ac by 2a. Is that formula used to find all the roots in if it is prime number also can be used to find the roots?
Yeah.
Even
This
prime
is a
numbers also.
general formula. So you can use it any case. For any quadratic equation, you can directly calculate the root using this formula. This is the general formula. Okay.
Thank you.
So if you have anything to ask, you can unmute yourself and ask. Okay. In between the class, I may not be able to read all the chat boxes. Okay. So if you have any doubt, you can simply unmute yourself.
We can use this formula na, instead of FOIL method and completing
Yes.
method, whatever.
Yes, definitely we can.
Hello.
Yeah.
Yeah, ma'am. The professor said about the limitation of the squaring method, and I didn't get that point. Could you explain that?
Which limitation can you say?
He said when the constant is negative, when you put in the right hand side, then there is because the square root of negative is not possible. But there he didn't give an example of that. So you could
Okay,
explain.
if this term is negative minus 4ac, if this is negative, then we
No, no,
will
no,
get no
no,
real
no,
root.
no, not discriminate.
No,
Not
I'm
he was
not this.
he was talking about the as a standard form of the quadratic equation, where the a square plus bx plus c. When you put c, which is a constant, in the right hand side, and I'm not able to explain the point right now, but
There is
can
a
you?
function which is x square plus 10x minus 24 equal to 0. So
X squared plus
for
10x
that,
minus 24 equals to 0. Okay.
yeah. So like we move like that 24, which is constant, to a right hand side
No, no,
for that.
it is it will have a roots, but
Yes. In this equation
So
also we
sir
can
said
apply
कि
this formula. Yes. Tell me what's that say?
then to solve this thing, like this function through computing the square method, that 24 like should be a positive value, like greater than 0. So Like this is the like kind of a limitation he mentioned there.
Basically indirectly saying of this discriminant only, because we can treat this simple step, right? 2 into 5x plus suppose 25, and then we will get 24 plus 25 here, right?
Yes, ma'am.
So here it is a perfect square, x plus 5 whole square, right? And here we are getting something positive. Here we are getting basically 49. Okay.
Yeah.
So if this is negative, okay, suppose this is negative, suppose, then this is not possible, right? Because here we have something positive and x is a real number, because we are taking x as a real number here. If x is a complex number, then it can be the case, okay? But here we're not considering the complex case even. If
Yeah,
x
yeah,
is
I got it. I got it. Right, I got it.
yeah. So because x is right, real number, then the square will be positive. So this side is positive value, this side is negative value. This is not possible, right? That's why professor said that this should be something positive. Okay,
Okay.
fine. Am I clear with the
Yeah.
point? This is basically
Yes, ma'am.
indirectly
Yeah,
saying
yeah, yeah,
of the
I got it.
discriminant. Yeah. So if this type of case is happening, then basically the discriminant will be something negative. This is nothing but the discriminant. Okay. Fine.
Yes, ma'am.
Any other doubt? Do you have any other doubt? Okay. So we can next talk about the slope. So we know that if we have a function of x, the slope at the point fx, the slope of fx at the point x is nothing but f dash x. Right? So in this case also, if we have the parabola ax square plus bx plus c, this is our fx, our y is same as our fx. So here we will do the derivative and then it will become 2ax plus b. So this is the slope at the point x. Okay. So I think in your slides you have the direct formula, right? So it is also coming from the derivative. It's basically same. So slope means what? Suppose we are going to calculate the slope at this point. That means the slope will just touch the curve at this point. Okay. So this is the slope. So I think some of you had some doubt with the slope. So you can ask your doubt. What was that?
Okay, single differentiation form of this polynomial is the slope.
Yeah, yeah. So if you generally, if you have any polynomial, any arbitrary polynomial, you can simply differentiate. It will be the equation of the slope. Okay.
Oh, yeah, yeah, yeah.
Okay.
And ma'am,
So
how we can find the point where the slope is touching the graph?
at any point, slope is what? Like if a graph is differentiable at some point, then we can say that the slope or the tangent will exist at that point, right? If a graph is differentiable at some point, then tangent will exist at that point, and it is vice versa. Like if tangent exists at some point, then the graph will be differentiable at that point. Here, because we have a polynomial function, so we have that all the polynomial functions are differentiable everywhere, anytime, right? So at any point, the polynomial functions are differentiable all over the real line. So at any point, the slope of the function will exist if you have a polynomial function. Okay. So
Okay.
if you have a non-polynomial function, then we can compute the slope only at the point of differentiability. Okay. But if we have a polynomial function, no need to be worried about the points, because at any point we can compute the slope. Like for this function, at this point, this will be the slope. At this point, this will be the slope. At any point, we can sorry. At any point, we can draw the slope, okay? Because the function is differentiable at every point. But if we have a mod x type of function, okay, suppose the graph of mod x, the function is not differentiable at that point, right? So at this point, we are not able to draw the slope. Okay, slope exists means there is a unique slope, right? So here we have the equation, and 2ax plus b is the only possible equation of the slope, right? And because a or b, they are arbitrarily fixed constant, so the slope is a unique line, right? But if you have some graph like that, at that point the slope be something like that, the slope also can be something like that, okay? So here at that point we cannot get a unique slope. That means we will directly say slope doesn't exist for mod x at the point 0. Okay. But if you have a polynomial function, because polynomial functions are differentiable everywhere, so slope will exist at every point. Okay. So I think these are all the concepts. So if you have any doubt, you can now ask.
Only this much in week 3.
What I remember this much was in week 3, but if I left any topic, you can remind me. I will cover it if any topic is left to cover.
Okay, ma'am.
Yeah. Anyone, if you have any doubt or anything I didn't
Ma'am,
cover,
can
you can yes.
If a coordinates in the this polynomial is given, then what we have to do is just put in the x and y's, and we have to just differentiate one, then we'll get the slope
Yeah.
at that particular point.
Yeah.
Okay.
So in this slope equation, you have, after the differentiating thing, I got the equation 2x plus b, right? So here x is some point. So x can be any point over the polynomial, okay? So you can take any point if you want to calculate the slope at that point. You can put the value of x there, then you will get the equation of slope at that point.
Okay.
The quantity, actually, not the equation. Equation is something general. So this is the equation. This is the equation, and you want to get the value of the slope, then you can put the value of x. If you were asked to calculate the slope of some, suppose x square plus 2x plus c at some point 2, I'm just telling you arbitrarily, okay? I don't know whether it is on the graph. So suppose at some point 2, then we will calculate the equation of the slope, and then we will put 2 instead of x, okay? So we can calculate the value at that point. Okay, so anything, if you have doubt, you can ask. Or if I left any topic I have to cover, like maybe I can forget to cover some topic. If you have in your mind, then you can remind me. I will cover it.
Just
you
2 minutes.
clear me
Just 2 minutes.
how hello ma'am?
Yeah.
Can you clear my one doubt how to write the equation in vertex form? Means if we are given vertex, then how to write it in a vertex equation form?
Okay, that I did this one, right? Using the completing the square method. Using the completing of square method, you can express any standard function to the vertex form.
Means ma'am, by this formula a bracket x minus h whole square plus k.
Yeah. So if you have this equation, we know the x coordinate is nothing but minus b by 2a, right? Vertex, the x coordinate of the vertex is minus b by 2a, right? So here the vertex is h. So obviously in both the cases, the x coordinate of the vertex will be same. So it's obvious na, that the value of h will be minus b by 2a. That's why I computed here. This is our minus h, right? You can relate them. If we have the equation in the standard version, then by the formula, we know directly the x coordinate of the vertex is minus 2 by minus b by 2a, right? So if we have the formula in, but if we have the equation in the vertex form, then we are getting directly that the hk is the vertex. That means h is the x coordinate of the vertex and k is the y coordinate of the vertex. So it's obvious na, that because the equation is same anyway. So the coordinate of the vertex will be same in both the cases, right? So x h will be minus b by 2a because h is the x coordinate of the vertex and k will be f of minus b by 2a. Okay.
Yes, ma'am.
Okay. Any other doubts? Any other conceptual doubt if you have, you can ask. With the pictorial explanation or anything. If not, we can end this class here also. But if you have doubt, we have time. You can ask.
I'll try to focus at the best of me. And could you please equation the quadratic equation?
Can you repeat? Can you repeat?
I'll try the best, and in this class itself, could you please clarify again that quadratic equation that you derived?
Which one?
If no one have any doubt, then only.
This one.
Ma'am, can you explain the
Ma'am,
equation of
tomorrow
parabola?
session will be like you will
Problem
be
solving.
solving some problem,
Yes.
ma'am.
Tomorrow we have an open session where I will discuss all the problems. It can be from your activity question, your practice questions. What is your deadline for the graded assignment submission?
Deadline
12 October.
16.
16 October.
October. Okay. So graded assignment we will not discuss. We will discuss all the practice assignments and activities. Also, we will discuss some extra. We can discuss some extra problems if we have time. Okay.
Madam, this related to b square minus 4ac, the greater than 0 or lesser than 0, that one. No? So the greater than 0, there is a one option is perfect square and there is a no perfect square.
Yeah.
Can you explain that one? Actually,
It is,
what is the square and what is not perfect square?
yeah. So basically, if this term b squared minus 4ac is 0, okay,
Yeah.
then okay, that means this term is 0, right?
Yeah, it's greater than 0. B squared minus 4ac is greater than 0. We have two types of that is a discriminant. That is a perfect square and not perfect square.
So basically, if it is not equals to 0, then not a perfect. The equation is not a perfect square. But if it is 0, then you can directly equate it with 0. Then the equation is basically a perfect square, right?
Yeah, madam. That is the b
That
squared
is
minus
fine, right?
4ac. B squared minus 4ac greater than 0. I'm not
Okay,
talking
it
about
is greater than 0.
0.
That means this term is also a positive term, right? Because we have a square here. So that means we have something positive here. Now, if we do the root, okay, then we will get plus minus of some number, some real number, right?
Okay.
Okay, we can get plus minus of some real number, or we can get basically, we will get some plus minus of some real number. Whether it can be within the root, it can be outside the root. If it is a perfect square, suppose this is root r. Okay, so if this r is a perfect square, That means if this is a perfect square, we will get a rational number. But if this is not a perfect square, we will get something within the root. That means we will get something, some irrational number, right? Which is
Yeah.
also the real number. So
Okay.
we don't have any problem. So we will get a plus minus kind of thing. So
Okay. Okay.
this
Got it.
plus minus will give us two different root. For one root for plus, one root for minus.
Okay. Okay.
Any other doubt?
मैम
I covered. Yes.
मैम मैक्सिमम एंड मिनिमम में थोड़ा प्रॉब्लम्स आते हैं.
What is the
मैं
problem?
आंसर क्लियर कर दूंगी.
क्या प्रॉब्लम है?
मैम मैक्सिमम एंड मिनिमम कैसे फाइंड करते हैं? थोड़ा.
Okay, so if you have a parabola, then the vertex is the maxima and minima according to the situation. If you have a parabola and you are
क्वेश्चन
asked to
आता है तो
calculate,
मैम उनको कैसे सॉल्व करते हैं मैम? मतलब मैक्सिमम कैसे फाइंड करेंगे मैम?
okay,
मैक्सिमम एंड
so suppose you have some x squared plus some, suppose 5x plus 6. This is a kind of, this is a parabola, right? Suppose you have to calculate the maxima. So what is the, this is our A, this is our B, this is our C, right? So x coordinate of the vertex, I'm denoting it with bx. So it will be minus b by 2a, right? And your b is here 5 and a is 1. So you just put the value, you will get minus b by minus 5 by 2. Okay. So this is the x coordinate of the vertex. That means this is the minima. This is not the maxima because this is positive. So we will get this type of parabola. In this case, maxima doesn't exist because this is going to going up to the infinity. The slice. Okay. So we will not get the maxima here in this type of case, but we will definitely get the minima. And this is the minima minus 5 by 2. Okay. And if we have something minus x square plus 2x plus 8, suppose, then the vx will be minus 2 minus 2, that means 1. Okay. So we will get this 1. This 1 will be the maxima then. Okay. This is the maxima. Okay. Simply, you have to just calculate the x coordinate of the vertex. The x coordinate of the vertex will be the maxima or the minima according to the situation. If the parabola is in the upward direction, then it will be the minima. If it is in the downward direction, it will be the maxima. If it is the downward direction, then minima will not exist. Only maxima will exist, and maxima will be the vertex. Same for the parabola in the upward directions. Okay.
Okay,
And
ma'am.
this
Thank you.
x-intercept, the x-intercept which we have here, minus b by 2a, this makes some similarity with the straight line equation 2. But how this 2 came here in this equation?
Can you repeat? I didn't get your doubt.
Minus b by 2a is the equation to find the intercept, na?
In this equation. So minus b by 2a is the vertex. Minus b by 2a is to find the vertex. It's not the intercept. For the intercept, you need to calculate the root. If you have the equation, you can calculate the root, right?
Yes, ma'am. Yes, ma'am.
So x minus x square plus 2x plus 8 is equals to 0, right? So you can take minus as common, you will get minus 8 equals to 0, right? So we can again apply the completing the square method. X square minus 2x plus 1 plus 8 plus 1, right? This is the completing the square method. So it will become x minus 1 whole square equals to 9. Okay. So it will become plus minus 3. It will become either 4 or minus 2. Okay. So 4 and minus 2 are the two distinct root of the equation. Okay. So the parabola will be something like that.
Wow. reading square equal of
This is -2. This is 4. And the vertex will be at the point 1. You can check the vertex is at the midpoint, right? Up to 1, this is we have to go 3 steps, and from 4 to 1 we have to come 3 steps, right? The vertex is the midpoint. Fine.
Yes, ma'am. Yes, ma'am.
So is the doubt cleared?
Yes, ma'am. Yes, ma'am. Cleared.
So any other doubt? If not, then we can close the session here. If you have, then you can ask, otherwise you can leave.
Okay, ma'am. Thank you, ma'am.
Yeah. Welcome.
Ma'am, actually, I had a doubt in the graded assignment of week 2.
The bro Mama has left the class.
Oh, has she? Okay, all right.
So is there anyone in meeting? Hello. Is there anyone in the meeting? Is there anyone in meeting? Hello. Yes, bro.